So what Pause, Think, Do physics is all about is to put in these little prompts every once in a while in a video to make you pause and really think about the solution to a particular problem that's asked. It's very easy to kind of sit and watch somebody do physics or watch somebody do math and kind of nod along and think you're understanding it. But what often happens with students is that when it comes time for them to do it on their own, they find that they can't. And if you can put yourself in the position of trying to think through the problems as often as possible, then that will really help you develop the ability to think on your own. And that's what we want to do here. So just to get a little practice with this, with pausing the video, thinking for a little bit, and actually doing some physics, we'll try that here. As a simple example, remember our formula that we have seen for the time it takes for an object to fall, which is the square root of 2 times the height that you drop it from. So here's some height h, and we know that the gravitational field strength is around 10. It's technically 9.81, but we'll just call it 10 meters per second squared. We're going to be digging into that a lot in this class. We haven't talked much about it at all. But how would you use this now? So go ahead and see for a height of, say, 5 meters, see if you can pause the video, think, and apply this, and calculate how much time it would take to fall in seconds. Pretty easy problem, but I'm just trying to get you in the habit of pausing, thinking, and actually doing some physics on your own. So write it down on paper and try it. All right, so hopefully you were able to do it. Very easy problem. You just plug in your numbers that you're given. So we've got 5 meters, and we're going to keep the units inside of our expressions here, and then we'll also plug in 10 meters per second squared. Now, it's always good practice to plug the units in and then cancel them out, so the meters will cancel there. And if you're good with your algebra skills and manipulating these formulas, then we could write this as the square root of 2 times 5, which is 10, divided by another 10, and then we have 1 over seconds squared there. And this is going to turn into the square root of 10 over 10, and then seconds squared. Notice that this is not a variable, that little s, that is a unit, seconds, and it's squared. So if we take the square root of something that's squared, then we just get that thing. And so easily this ends up becoming 1 second. And there's our answer. So you drop something from a height of 5 meters with no air resistance from rest, and it'll take 1 second to fall and strike the ground. Pretty cool. Now, studying physics is all about change. It's all about how we change certain parameters of a system and see how those changes manifest. So, for example, what if we dropped the ball not from 5 meters, but if we dropped it from 10 meters? How would that play a part in this physics? Well, we could plug in 10 meters and we could solve, and we would get 1.41 seconds. It would be an easy problem. You just plug it in like you did before. But there's something much deeper going on here mathematically that I want to kind of share with you today. And we'll be thinking about this throughout the year. It's a skill called proportional reasoning. And we're going to quickly kind of go through and show you something neat. So look at what I've done. And I've solved, or I've written out this expression for the time to fall, but I've been specific by using what are called subscripts. So the time for ball 1 to fall is the square root of 2 times the height that ball 1 was dropped, divided by g here, all under the radical. And notice that g is the same, the gravitational field strength is the same for both objects, and so I don't have to put a subscript for g. That's an important point. Now, notice the relationship between the two heights. Hopefully you can see clearly that height number 2 is some factor times height number 1. Why don't you try to pause the video for a second and figure out what this number is. It should be obvious, but pause, get in the habit of doing this, and think through how this formula should look. What should we replace this number with? All right, so you got it. It's 2, right? So this reads like a sentence. It says that the height 2 is equal to 2 times height 1. Now, let's play around with that with the math, and I think you'll see something really cool. So I'm going to solve for T2, 2 over g, and I can plug in because I have an expression now for H2 right here, and I can plug that in here in that space. So let's do that. So we get 2 times H1. That's what H2 is equal to. And now if we keep going with the math, or how about you do that, right? Why don't you go ahead and continue with the algebraic manipulation of this and solve for this expression, see what you can come up with. And then then after you do that, why don't you look back at this expression over here for T1? And in doing so, see if somehow you can figure out why the answer to our question in class was what it was. Specifically, if you get it right, you're going to find this final result. You're going to find that the time it takes for ball 2 to fall is going to equal the square root of 2 multiplied by the time it takes for ball 1 to fall. So see if you can figure that out on your own. Pause, think, and do some physics. So let's take a look together. We'll solve for T2. And if you just play around inside the radical here with the math, you're going to get 2 times h1 over g, and then multiplied by another 2 all under the radical. And I hope you can see it, and I'll do this in a green color, I guess. This whole expression there, radical 2h1 over g, is the same as this right here. And if you're good with your square root math, you'll then be able to show, and I'll do it right underneath oops, let's do that in the same color here, that t2 is equal to the square root of 2 multiplied by 2h1 over g, and that expression there is just t1. So we get root 2 times t1, and there we have it. Now that seems like a lot of work to do just to get to this result. We could have just plugged the number in, of course, and gotten it, but you'll see that this way of thinking more abstractly and seeing how systems respond to changes will be very, very powerful. In fact, just as a quick note, we won't solve this now, but what if we solved a problem like this, where we, instead of doubled the height, instead we went ahead and say tripled the height. So maybe h2 was equal to 3 times h1. How would that play out in all of the math without having to go plugging in and chugging with the numbers like we did at the very beginning of this video? Okay, so we're laying the foundation for what's called proportional reasoning and for this quick ability to see how relationships in physics respond to changes. And I think you'll find that a really important skill to add to your tool set here. All right, so take care. We'll see you in the next video.